Let's look at how we can write an equation for the log function that is graphed here. So first, we can note that this graph has been shifted to the left 3 units. We can see that by looking at where we have a vertical asymptote at x equals -3. So this means we have shifted left 3 units. This is as important as we go to think about the format for our function. So we can think of it as f of x is some leading coefficient a, we'll come back to find that, and then write it as log of x plus 3 plus k in case there was some kind of vertical shift. So the x plus 3 on the inside is what we find from having the graph shifted to the left 3 units. Let's pick out a point on the graph, plug that in, and start finding our constants. So here we see a point at -2, 0. Let's plug that in. So we have 0 equals a times the log of -2 plus 3 plus k. Well, -2 plus 3, we have the log of 1 plus k. But we've seen before, log base anything of 1 is equal to 0. And so here, log base 10 of 1 is equal to 0 because 10 to the 0 power would give us 1. But a times 0 means that piece is going to drop out. So on this particular function, k is equal to 0. So it means that we don't have a vertical shift of any kind. So now let's find another point on our graph, see if we can find our leading coefficient of a. So another point we could use is the point 1, 2. So I'm thinking about my function as a times the log of x plus 3. I don't need my plus k now that I know that k is equal to 0. So plugging in, I have 2 is equal to a times the log of 1 plus 3. So 2 is equal to log a times the log of 4, and a is 2 divided by the log of 4. So putting this all together, our function, f of x, is 2 over the log of 4 times the log of x plus 3. So this is one way that we can write our answer. It's an exact function that represents this graph that we have. We could put this into Desmos or a graphing calculator and compare and see these same points that we found on our graph. But thinking about our change of base formula, since I have a log of x plus 3 over a log of 4, I also could put those together, and instead of writing this in terms of base 10, another way I could write this same function is 2 times log base 4 of x plus 3. So I'm just using my change of base rule, but in reverse. And so really all I'm doing is I'm looking at these two and thinking about, okay, if you have the log of x plus 3 over the log of 4, this is the same as having log base 4 of x plus 3. So it's our change of base rule from a previous section that allows us to say this. Both functions are correct, and both would match up with this graph that we're given. One is written in terms of base 10, one is written in terms of base 4. They're equivalent, they say the same thing, just in different ways, but both are completely correct to represent this function that we have in our graph.